Question 18 is a tricky one, and there was a really similar one in the mock at the end of year 10, which threw a lot of people. But if you follow the clear steps I'll give you, it is very manageable. So we're given that g is equal to x over the square root of y, and we're given the values for x and for y, and they're rounded. So the first thing we want to do is to calculate the bounds for x and y. Remember how we do that, we can halve the place value it's been rounded to. So for x, that's to 4 significant figures, which here we can see is a second decimal place. So that's 0.01. If we halve that, we'll get 0.005. We take it away from this for the lower bound, we add it for the upper bound. So for the lower bound, it'll be 0.415. And remember which way around these inequality signs go. And for the upper bound, we add it. We do the same for y. This is to 3 decimal places. So that's 0.001. We're going to halve that. 0.0005. We take it away for the lower bound. And we add it for the upper bound. And you can also see here, so to 3 decimal places we were told. And we can see we've gone up 1 in that place value. Here was 4 significant figures, which was the same as the second decimal place. We can see here that pattern again. We've gone up 1 in that place value. We're asked to then consider bounds and to work out the value of g to a suitable degree of accuracy. Got to show our working and give a reason. So we need to find the lower bound for g, and we also want to find the upper bound for g, and then we're going to use those to give a value of g to a suitable degree of accuracy. To get the lower bound, the smallest possible value, we want to have the minimum value of x, the lower bound of x, divided by the square root of the highest value, the upper bound for y. And I'm not rounding the answer there, I've just put it to 4 decimal places, which should be enough in a question like this. To find the largest possible value of g, so the upper bound, we need to be using the upper bound, the largest possible value of x, and divide that by the smallest possible value of y. If you get to this point, you've already earned 4 out of the 5 marks. The last thing we need to do is give the value of g to a suitable degree of accuracy. And for this, what we need to do for these 2 values we've got, we need to find the smallest place value, which would round to the same value. So if this was rounded to 2 decimal places, it would go to 9.45. If this was rounded to 2 decimal places, it would also round to 9.45. We can just check we can't be more accurate. If this was to 3 decimal places, that would go to 9.449, and 3 decimal places for the upper bound of g would go to 9.453. So we can see these are different. We can't use those values, so it's to 2 decimal places, and it's a value of 9.45. So our final answer is g is 9.45, and that's a suitable degree of accuracy as both the lower bound and upper bound round to this. And that's the reason we're asked for our final answer for that last mark.